Okay, so when we multiply these, what are we actually going to do here? Distribute, right. So if you're struggling with this, make sure that you're writing it out. Don't try and do too much in your head, okay? So first of all, let's all get some paper out so we can take some notes, right?
That's fine. Can I do it on my Can I just look at? Yeah, I can do it on my iPad.
Okay.
I already submitted it, so if it says it's unsubmitted.
That's okay. I can see. I'll see that you submitted it already. Okay, so this is going to give us, I'm going to put it in parentheses so I can keep track of my distributing. This is the square root of 10 times 4 root 2. And then we're going to do plus, and we'll distribute to the next term. The square root of 10 times the square root of 6. Okay, so I haven't done any of the multiplying yet. All I've done is write out the distributing, okay? So now we'll do our multiplying. So we're going to multiply everything that's on the outside. Well, the only thing on the outside here is a 4. And then we'll multiply everything on the inside. Well, I have a 10 and I have a 2. Okay. Remember, we're not actually going to multiply it because that's just going to give us extra work. It's not wrong, but it gives you extra work because ultimately we're going to try to simplify this. Okay. So then we're going to have plus. Now in this parenthesis, I don't have anything on the outside, so everything is on the inside. 10 times 6. Okay. So let's go ahead and figure out this radical. So 10 is the same thing as 5 times 2 times 2, which means now I can take these 2's out. So I have 4 times 2 on the outside, and I have 5 on the inside. And then over here, we have 5 times 2 is 10, and 6 is 2 times 3. So that means I can take these 2's out. So that becomes 2 square root of 5 times 3. So I end up with, let's kind of bring it up here, 4 times 2 is 8. So that's 8 root 5 plus, we've got 5 times 3 is 15. So 2 root 15. And we're done. Okay. Multiplying everything outside and then everything inside. Shani, yes.
What if you just left it like 5 times 3 instead of making it 15?
I would like you to take it all the way. Just go ahead and multiply that. It's okay if you did that on the worksheet, but like when it comes time for our test next week, I'm going to make sure that you multiply it out. Okay? Other questions? I'm going to turn these lights on. People can complain about glare.
That's much
I wonder if it almost seems like since we got back from break, I've had more complaints. I wonder if it's just because it's an hour later or an hour earlier. It's actually an hour earlier.
Yeah, it's an hour earlier.
The location of the sun, I wonder if it's giving us more of a glare. Okay, so let's look at the next one. Anytime we have a negative number in there, it just seems like it makes it more complicated, right? We just have to be really careful, okay? So we're going to do the same thing again. We're going to distribute. So I have negative root 3 times 3.
Does that mean that it's really 1128? Like technically?
Yes.
No, not really, because it was daylight saving. So
I don't know which one it actually is because in the fall we fall back. Spring we spring forward, so I'm not sure where it's actually supposed to be.
Because when it started, my car clock, it said I'm be honest.
Doug.
So
Just-
yeah, but I don't know whether the actual, like, if we didn't do daylight savings time at all, I don't know whether the actual time is what it would have been in the fall or what it is now. I don't know.
How does that? But like,
That's what it is right now.
How do you change time? Like, it's for the farmers.
No, that's not. She's not. That's
No,
that's
it's not.
absolutely
I just
correct.
didn't understand like what it. I just
No, it's not. That was. You're right. That's absolutely correct.
I don't understand how exactly that works. I guess I don't understand.
We're not actually changing time. We're just recognizing it differently. Not everyone does it,
Yeah.
so which makes it even more complicated.
So like we don't really have to. Like, but would it change anything?
So, yeah, I forget when it started. Anyone know when it started?
I can look it up.
Yeah, I think it was the 40s actually. It was it was either the 30s or the 40s. I think it started in relationship to it was in relationship to the struggling economy. And the idea was exactly that, to have more 1916?
1960.
I thought it was before that.
I don't know. I'm looking at Wikipedia, but I don't trust.
No.
But anyway, the idea was that in the wintertime, we have such little daylight time that by springing forward, I think that's what it is, springing forward, we get more daylight time. I forget exactly how it works. But the idea is that by doing the daylight savings time, we're actually allowing for more daylight time for businesses and for farming and things like that.
If we get rid of daylight savings time, crime rates would actually go down.
And how do you know that?
The internet. Researchers have found by extending evening daylight hours, as we do in the spring, crime rates actually go down, with robberies being reduced by 7% from the day before, and overall crime going down by 27%. An additional evening hour of sunlight gained on that day. I don't know if it's reliable.
Does that make sense to you?
No.
Oh, I think it makes sense. I think it makes sense. When it's dark, there's more. I mean, if your business is open when it's dark, you're more likely to be a victim of crime than you are in the daylight. So if you're a store that's staying open till 7 or 8 o'clock at night and it gets dark at 5 o'clock, you've got more time in darkness. Therefore, you're more susceptible to crime.
How do you extend evening daylight hours? You don't.
You don't. You just change the clock. You're not extending.
So that
We have the same number of. If we didn't do daylight savings time, like if we never sprung forward, right, we would have the same number of daylight hours that we have right now. It's just that we've changed the clock. So you notice when you get up in the morning, it's darker.
Yeah.
Right? So we're getting the same number of daylight hours. So when we get up, if you get up at 6 o'clock, that's the same thing as getting up at 5 o'clock before spring break. It's the same daylight. So it's just that we've changed the clock. So like before daylight savings time, right? Before daylight savings time, okay, the sun rose here, the sun went down here, right? Before daylight savings time, let's just pretend that this was 6 a.m. and that this was, 7 p.m., okay? After daylight savings time, the sun rose here and the sun set here. But now we're calling this 7 a.m. and we're calling this 8 p.m. It's the same amount of daylight. We're just giving it a different time so that we can adjust our business schedule and our farming schedule accordingly.
Okay.
Okay?
But how does that help farmers? Because it still gets dark at the same time, doesn't it?
No, it gets dark like 7:30 instead of like 6:30.
I'll do my research. I'm sorry. I just.
It's okay. It's all right. We know we won't put you in charge of that part.
Thank you.
Okay. We'll put Yana in charge of that. She's in charge of daylight savings time. Okay. So let's see here. Whew. We are distributing. So we've got negative square root of 3 times 3 plus we're going to distribute negative square root of 3 times the square root of 2. Okay. So, Ava, what do we do with this first parenthesis? Oh. What do we do with the first parenthesis?
Multiply them.
And what do we get? No, don't look. You know. Trust your brain. You know how to do it. Look up here.
3. Just 3.
Why am I getting just 3?
Because you said they're the same. It just,
Okay, good. If they're the same, we just drop the square root out of there, right?
yeah,
Are they the same?
basically, yeah. No,
Is the square root of 3 the same as 3?
yeah, basically.
Okay, let me rephrase that. Let me do it differently and give me a number that you can wrap your head around. Is the square root of 4 the same as 4? What is the square root of 4?
2.
Is 2 the same as 4?
No.
No. Speaking of that, let me show you a cool math thing. Totally unrelated to what we're doing.
You should close all your tabs.
No, I don't want to close all my tabs.
Yeah, do with the mumbles.
What the hope in
I do that on my phone, and then I have like 50 tabs that I need to.
Okay. Wait a minute.
Let's just get rid of that.
What does 1 plus 1 equal?
2.
2.
I bet I can show you that it equals 3.
You're wrong.
Oh.
Remove the minus sign. This 1.
No, I'm not gonna, no trick. Okay, I'll show you. Okay, here you go. Ready? Okay. Do you agree that 1 equals 1? Okay. So let's rewrite that as 41 minus 40. Does that equal, is that the same as 1?
Yeah.
Okay. And how about over here if I do 61 minus 60? Is that the same as 1? So I'm still saying that 1 equals 1, right? So let me rewrite 41 as 16 plus 25. Anyone want to check that? Does 41 equal 16 plus 25? Okay, it does. 41 equals 16 plus 25. Okay, minus 40. Okay, and I'm going to rewrite 61 as 36 plus 25. Does that equal 61? Check it on your calculator. Don't just trust me, check it. It does, okay, and then we're going to do minus 60.
Oh, 65. You said
Okay.
65?
Well, you're looking at it, right?
But you said does it equal 65?
61.
Oh, yes.
Okay, now 16. Is that 4 squared?
Yes.
How about 25? What's that?
5 squared.
5 squared. Okay. Minus, let's do, we're going to rewrite the 40. We're going to write it as 2 times 4 times 5. Do you agree that that equals 40?
Yes.
Okay. All right. So basically I have 4 squared, I've got 25, and 5 squared minus, and then this, right? So now let's write 36, that's 6 squared. 25, that's 5 squared. And we're going to do 2 times 6 times 5. That equals 60. 2 times 5 is 10. 5 times 6 is 60. Do you all agree with that? Everything okay so far? Okay. So now, what do I want to do here? Uh-oh, I just lost track of what I want to do. Hold on a minute. Oh, okay. Let me rewrite this now. This is going to be 4 squared. So I'm just going to take this and I'm going to move it in front there. So I'm going to do minus 2 times 4 times 5. Okay. Plus 5 squared. Are we allowed to do that? Can we move that over like that? So if I had like 3 plus 6 minus 2, could I rewrite that as 3 minus 2 plus 6? Sure you can.
Oh,
Same thing, right? Same thing. So that's all I did. Okay. Okay, so now let's do the same thing over here. Let's rewrite this 6 squared. Oh, this is a minus, sorry. Minus 2 times 6 times 5 plus 5 squared. Are we okay with that?
Yes.
Okay. So, okay. I just lost, why do I keep losing track of where I am? What did I just do? I just moved that over. Okay, what else could I do? Because I want to prove that 2 is equal to 3. So, I'm going to tell you that this is equal to that. That whole side is equal to that. Do you believe that? Okay, let me do this. All right? So I'm claiming that that whole side is equal to that. Well, let's just look at this. 4 minus 5 times 4 minus 5. Okay? Let's FOIL that out. Let's distribute it. Right? What do I do when I do that? We do,
16.
let's just write it as 4 squared, okay? And then we're going to do plus 4 times negative 5, right? And then we're going to do plus, this is negative 5 times 4. Everybody okay with that? And then we're going to do plus, this is a minus times a minus, 5 squared. Huh? It's the same. Yeah, we get 4 squared plus, right? We've got 4 times
Negative 20.
4 times, holy smokes, negative 20, thank you very much, plus negative 20 plus 5 squared. What's this equal? Negative 40, right? So I've got, come on out of the way, there you go. I've got 4 squared minus 40 plus 5 squared. Well, let's look at this. This is 4 squared. What is this? 40 minus 40 plus 5 squared. Right? So I just showed you that 4 minus 5 squared is actually the same as this up here. Everybody follow that? Okay. So now, so I rewrote the left side. I'm going to do the same thing on the right side. I'm going to rewrite it. Basically, what I'm doing is I'm factoring it. So on the right side, right, this is going to be equal to 6 minus 5 squared. Do you all believe that that's true? Okay, I'll show you again because this is key to the whole thing. Let's multiply that out. That gives me 6 squared when I distribute minus 6 times 5 is 30, minus 30 again, and then plus 5 squared. So we get 6 squared minus 60 plus 5 squared. Well, that's what we have up here. This little piece right here is 60. Is everybody okay? Well, if I have something squared on both sides like that, right? Like let's say that I had x squared equals 9. Then what does x equal?
3.
3, right? We take the square root of both sides, right? So what happens if I take the square root of both sides here? If I take the square root of both sides, right? What's the square root? Okay, guys, pay attention. What's the square root of x squared?
So it's
X. So what's the square root of this squared? Yeah, 4 minus 5. What's the square root over here? 6 minus 5. Okay. What happens if I add 5 to both sides? I get 4 equals 6. So what happens if I divide by 2 on both sides? 2 equals 3.
Teachers and students, please excuse the interruption
2
at this time.
is 1 plus 1.
Assistants with today's math, please start making their way over to
There
the
you
church.
go.
This will be
1
our
plus
office
1
servers,
equals
blessers,
3.
the choir, ushers, and our audio visual. Again, please keeping your items in the classroom that you're in now. No outerwear, phones, water bottles, or gum, please. Thank you.
All right.
Yana say no, 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 no. Should we look at it again? Did I do anything that was wrong?
That's a lot of work just to get one.
His math is better, I feel.
Had to have done something wrong?
no.
Let's look at it. Let's look at it.
Or did it purposely wrong?
Let's look at it. Okay, I'll go through it again
It's
now.
just math, bro.
Okay,
It's just math.
let's go through it again. Here we go. Right? 1 equals 1.
Yeah.
That's true. 41 minus 40 equals 61 minus 60.
Yes, it will.
That's true. Okay. Now, instead of 41, I wrote 16 plus 25. So 16 plus 25 minus 40 equals 36 plus 25 minus 60. Is that true?
Yes.
Sure. All I did was substitute out those, right? Okay. So now, instead of 16, I wrote 4 squared. Instead of 25, I wrote 5 squared. And instead of 40, I wrote 2 times 4 times 5. Right? This is 40 right here. So that's true. Instead of 36, I wrote 6 squared. 25, I wrote 5 squared. And instead of 60, we did 2 times 6 times 5. So there's our 60. Everybody agree?
Yes.
Okay, tell me where the mistake is. All right, all I did here was rearrange. You can change the order that you add or subtract. There's nothing wrong with that. You can change the order that you add or subtract, and that's all I did here. Okay? Now, I factored this, right? And I just showed you, remember, this is 40 and this is 60. And I showed you that 4 minus 5 squared is equal to 4 minus 5 times 4 minus 5, right? Which gives me, if I FOIL, I get 16 minus 20 plus 25, right? That's 16 minus 40 plus 25, which is what we have up here, right? 16 minus 40 plus 25. So I factored it. Then I took the square root of both sides. When you take the square root of something squared, what happens? It just drops out. The square root of x squared is x. The square root of 3 squared is 3. So that gives me 4 minus 5 equals 6 minus 5. We add 5 to both sides. We get 4 equals 6. Divide by 2 on both sides. We get 2 equals 3. And 2 is 1 plus 1. Doesn't that bother you?
No, not really. No.
There is a mistake. There is a mistake. 1 plus 1 does not equal 3. We know that. We know that.
Well, I thought
Why is there a negative 5
Negative 5. What are we talking about?
in the 4 minus
Oh, this is, oh, wait a minute. Oh yeah, that should be a -5 because we factored it. 6 minus 5 squared equals 6 squared plus 5 squared minus 60.
Yeah, but
That is actually true.
so we're looking for a mistake.
Could you do the last part again?
Which part?
Like, from starting from 4 minus 5 equals 6 minus 5, and then you add 5 on both sides.
Okay, what do you want me to do?
Like, you just say it again.
Okay, 4 minus 5 equals 6 minus 5. So now I'm going to add 5 to both sides. And when we're dealing with equations, we have to keep it balanced. So whatever we do on one side, we do on the other side. As long as you do the same thing on both sides, that's okay. So that means that I have 4 equals 6. Now if I divide both sides by 2, I get 2 equals 3. And 2 is 1 plus 1. There is a mistake. Katie. Well, remember, I was trying to prove that 1 plus 1 equals 3.
Can you go down? 4 minus 5. That's 1. Then plus 5. That'll be 6, not a 4.
What?
What?
That's right.
So
Okay.
you got 4 minus 5, right?
Here's the mistake. The mistake is here. Okay, so, all right, if I said x squared equals 9, what does x equal? Why do we know that x is equal to 3? Because 3 times 3 equals 9, right? Well, doesn't -3 times -3 also equal 9? Okay, so the mistake here is that when I take the square root of both sides like that, it should be a plus or a minus. I'm assuming that there's only one square root. So in this step here, you can't simply take the square root and assume it's the positive number that we're referring to, because it could be the negative number that we're referring to. And that's where the mistake is. Okay? I'll show you another way of doing it, because this is just fun math. This is just like fun with numbers. This is fun. Okay. Let's prove that 1 is equal to 2. Now we know that's not true, right? Okay, so now you have to follow this, okay? So we're going to say, let's let A equal B. We're going to start off with the assumption that A is equal to B. We don't know what A represents. We don't know what B represents. But we're going to make the statement that they equal each other. They're the same, okay? So if I multiply both sides of that equation by A. Whoops, let me rewrite that so I don't confuse you. I'm going to multiply both sides of the equation by A. Are we okay doing that?
Yes.
If A equals B, then A times A is equal to A times B. Do you follow that? Okay. So that means that A squared, A times A is A squared, is equal to AB. Good with that? Okay. Now I'm going to subtract B squared from both sides. Anyone have an issue with that? Who remembers how to factor A squared minus B squared? If I was factoring x squared minus 16, and who remembers how to do that? Yeah. Plus or minus, right? Take the square root of 16, which is 4, right? So how would I factor A squared minus B squared? What's the square root of A? Okay. What's the square root of B? B. So we have to have a plus B and a minus B. So we factored the left side. Who remembers how to factor the right side? How to factor this? You have a greatest common factor. What's the greatest common factor? Looking this part right here. What is it? B. Take a B out. And what are we left with? A minus B. Okay. Okay. So now I'm going to divide by A minus B. What do you think is going to happen when I divide by A minus B? What cancels? A minus B cancels. So we have A plus B equals B. All right. Well, in the beginning, I said A is equal to B. So I can rewrite this. Instead of A, I'm going to write it as B. B plus B equals B. Well, if B plus B equals B, that's 2B equals B, which means 2 is equal to 1. And then we just proved it. I know. Which B? This B right here?
Yeah.
Because in the beginning we said let A equal B.
Oh, I get it. You substituted the B as a
This is a really good example of how people can twist the truth.
Yeah.
Right?
It's easy.
We can twist the truth, and it's like you in your gut is saying no, it's not true, but you can't find the flaw in the logic, can you? Right? There is a flaw here, but it's hard to find that flaw. Right? This is a really good example. People can use the truth to come up with a false truth that sounds or looks reasonable, right? So you got to trust your instincts. Okay, so enough fun with math. Let's do some non-fun math. Okay. Okay, so let's see. What other ones do you want me to go over? I think a lot of people had trouble with number 6, right? No? We're just writing it like this, right? Okay, what ones did you have trouble with then? Number 8? Did I hear someone say 8 before? You guys are not working on other things, right? We're back to math now? Okay, let's do number 8 together.
Let's do number 7.
Okay, I'll do 8 and come back to 7.
Okay.
All right, so we're going to distribute. So we have 3 square root of 5 times 3 square root of 5. Okay. Plus, we do it in different colors. Maybe that'll help. Okay, we're going to do 3 square root of 5 times 5 square root of 3. These numbers are so similar, we've got to take our time so we don't get them mixed up. And then we're going to do plus square root of 3 times 3 square root of 5 plus we have the square root of 3 times 5 square root of 3. Okay, so all we did was write out the distributing. Okay, so the first parenthesis here, we're going to do the outside. 3 times 3 is 9 times the square root of, combine the inside, 5 times 5. We'll come back later and simplify that. Plus the outside, we have 3 times 5 is 15 times the square root of 5 times 3. Plus the outside, here we just have a 3. And the inside, we have 3 times 5. Plus the outside, there's a 5. And on the inside, we have 3 times 3. Okay. So we combined our outsides, combined our insides. Now we're going to go back and simplify it. So here we get, the 5s are going to come out, so we get 9 times 5. Plus, nothing comes out, so this remains 15 square root of 15. And then we have plus 3, nothing comes out, so that's square root of 15. And then plus 5, the 3s are going to come out, so 5 times 3. That leaves us with a final answer of 45. Oh, this is not our final answer, actually. Plus 15 root 15 plus 3 root 15 plus 15.
I forgot to do the 45 and 15. I forgot
To multiply them together. Okay, one last thing we have to do. Anyone see it?
Yeah, let's go combine your like terms.
Yeah, combine our like terms, right? So these are like terms. So we have, if I have 15 root 15s plus 3 more root 15s, that gives me 18 root 15. Okay, and then we have 15 plus 45, which gives me 60. So that's our final answer right there. Okay. Questions? Okay. What time is this period going on for us? Oh, we got lots of time. Okay, do number 7, and then we're going to look at some division. Is this an absolute emergency? Okay. Okay, we're going to distribute. So we get 5 times negative 2 plus, we're going to distribute again, and we get 5 times the square root of 5 plus 5 square root of 5 times negative 2 plus 5 square root of 5 times the square root of 5. Okay. So this gives me negative 10 plus 5 square root of 5. Okay, and this is going to be a minus 10 square root of 5 plus 5 square root of 5 times 5. So we'll take that out. And this becomes 5 times 5. And now let's combine our like terms. So 5 times 5 is 25, all right? So we have negative 10 plus 25, that gives me 15, minus 5 root 5 minus 10 root 5 gives me 5 root 5. And that's our answer. Okay? What do you think?
I got that second one.
Okay, ready for some division?
Like dividing it now?
We're going to divide now.
it. Is it easier or harder?
It's about the same. Okay, so let's start off easy. 3 over the square root of 7. Okay, we cannot leave a radical in the denominator. Okay, so what we're going to do is we're going to multiply by whatever that radical is on the top and the bottom. Okay, you can't just randomly multiply a number by something. However, if we have the same thing on the top and bottom, what does that fraction equal? 1. And if I multiply something by 1, it doesn't change its value, right? Remember, 1 is the identity element. So if I multiply by 1, it doesn't change its value. So I like to think of this as just changing the way it looks. It's the same person. They just got a makeover. Okay? We're just changing the way it looks. So we're going to multiply by the same thing on the top and the bottom. So when we do 3 times the square root of 7, can't really do anything with that. That's just 3 root 7. But on the bottom, we have the square root of 7 times 7. And what happens when we do that? Just equals 7, right? And that's our answer. Okay. So if I have 8 over the square root of 2, what do you think? Anya?
So,
Go
I
ahead.
don't understand what you did. Like, with
So I'm trying to get rid of this radical that's in the denominator here. I'm trying to get rid of that.
Yeah.
So in order to do that, I'm going to multiply the top and the bottom of this fraction by that square root of 7. Okay? When we multiply a fraction, we go straight across the top and straight across the bottom.
okay, so then you're going to do the square root of 2 over the square root of 2,
Yes, exactly.
and then multiply it.
Yes. Okay. So on the top, we get 8 square root of 2. And on the bottom, what do we get?
2?
2.
That's it?
What do you think? Caden, why not? We can simplify it. How does this simplify? 8 over 2 simplifies to 4 over 1, or just 4. So that's going to be 4 root 2. So make sure you look to see if it'll simplify. Okay. Be very careful. These 2's do not simplify. If I had 2 over 2, we know that would simplify, right? But this is not 2 over 2. This is the square root of 2 over 2. So they don't simplify. They're not the same. So be careful. You can't simplify a number inside the radical with a number outside the radical. Okay? Let's do another one. How about 5 root 3 over root 2? So where's the problem? The one on the top is actually not a problem. It's the one on the bottom. You can't have a radical in the denominator. So we're going to do the same thing. Yeah, multiply the top and the bottom by the square root of 2. Okay. So on the bottom, on the top, what do we get? 5 square root of 6. And on the bottom, what do we get? 2. Can we simplify? No, because the 2's outside the radical and the 6 is inside. So that's our answer.
That's it.
Of course, we'll get harder. I have a little shortcut that I use, all right? I call it move and remove. Okay? This is my shortcut. So what we do, let me go back up to the beginning one here. Okay, I call this move and remove. So what we're going to do, we're going to move the radical up, right? So we already have a 3 there. Move the radical up. and remove the radical from the bottom. That's my shortcut. Okay? Look at this one. Move and remove. So what are we moving? The radical 2. And then we remove the radical from the bottom. Okay? So what if we had 7 over the square root of 5? Use the move and remove to simplify that. So we're going to move radical 5 up top and remove, so what's left on the bottom? 5. Okay? Doesn't that simplify it? Okay. What if we had 3 root 6 over root 2? Move and remove. So we've got 3 root 6 up there. And when I move, I'm going to move the root 2 up top. On the bottom, we remove the radical. So this just becomes 2. Okay. Jonah, what you working on? Okay. So up top, what do we have? 3 radical 6 times 2. Okay. Where can I go with that? Yeah, let's factor this down. 3 times 2 times 2 over 2. So once we move and remove, then we have to simplify it if possible, right? So that's what we're doing. We're simplifying it if possible. So here I can take these 2's out. So this becomes 3 times 2 root 3 over 2.
Bless you.
Which is 6 root 3 over 2, which reduces to 3 root 3. Okay. These potentially have a lot of steps.
Because we divided this 6 by 2.
Yes. These potentially have a lot of steps. You just have to keep chugging along until you feel like it's fully simplified. So, excuse me, one of the things that we make mistakes with or we struggle with is as soon as you do that first step, you're very proud of yourself, which is fine, right? And you're like, oh, I'm done, but we're not because we have to keep simplifying. So then you get to this and you're like, I'm done. No, we're not because this can simplify. Then you get to this step here and you get all excited. And you're like, oh, I got that. That simplifies to that. Great. And you're like, okay, 3 times 2 is 6. Yay. And you start doing your happy dance. But we're not finished because it can still simplify. So keep simplifying until you can't go any further. Okay? Just keep pushing through it. Don't just do your step and then move on. It's not a race. Okay? This is not a race to see how fast you can scribble work down. Okay? Okay, let's look at another example. Let's look at, oh, actually, let me give you these papers and then we can work on them together. Yeah, sort of, kind of. Not all of it. Okay, so let's simplify these, right? All right, so the first one, we have 5 root 15. Will the square root of 15 simplify? No, 15 is 5 times 3, so that's not going to simplify. over 2 root 4. Square root of 4 is going to simplify, right? So think, like, use your brain. Think first. Don't just plow into it. Because I know many of you were thinking, oh, multiply by square root of 4, right? You're all excited, okay? It's not wrong. It's just not going to lead to a simplified answer. So let's rewrite this. We've got 5 square root of 15 over 2, and then the square root of 4 is 2. So 2 times 2. So that gives me 5 root 15 over 4. Can we simplify that anymore? No. So now we can do our happy dance. Okay, happy dance. Woo! Okay, there's my happy dance. I dance so poorly I have to accompany it with the woo, just so that you know it was a happy dance. Okay. Okay. Let's look at number 2. We've got the square root of 12 over the square root of 25. Okay. What are your thoughts? Sure. Yeah. Okay. We can simplify them first. Let's start with the denominator. What's the square root of 25? Okay. How about square root of 12? 3 times 2 times 2. 6 times 2, right? Which means the 2's come out. And we're done. Bless you. Okay, let's look at the square root of 12 over 5 square root of 16. Okay. So we just did the square root of 12 on the one above. So what's the square root of 12 equal? 2 square root of 3, right. Good. Okay, we good? Nope.
Oh,
Yes. There we go. Square root of 3 over 10. Okay. We're only going to do 3 more, and then we're going to call it a day.
Wait,
Just totally.
how we get the 3 up at the top? Like, where did the 2 go?
The 2 and the 20 reduced to 1 over 10. So there's a 1 here. Okay. Okay, number 4. Now we just all of a sudden got harder. Negative 4 plus 4 root 3 over 4 root 9. How come it's not that bad? Tony. They can. How would they cancel out? Okay, so this one is a little bit confusing for that reason. So since they all have a 4, right? If it was just 4 over 4, what would that equal? 1, right. Since they all have a 4, we can rewrite this with all 1s instead. So negative 1 plus 1 root 3 over 1 root 9. Since they all have a 4, they have to all have it in order to do that. I don't need these 1s right here outside the radicals. Okay, the only way you can do that is if they all have that same number. Okay.
So if you weren't so if you weren't to do the 1.
So if there was a 4
Right. If there was no 4 right here, you couldn't do it. Okay. Yes, Jakai.
Can't you just do negative 4 divided by 4 on the bottom and cancel it out?
Yeah, it looks like you could, doesn't it? And this is probably one of the most confusing parts about fractions, right? Let me just work with numbers, right? Let's say that we had 4 plus 3 over 4, right? That equals 7 over 4, right? Well, if I canceled out these 4s, made this a 1 plus 3 over 1, that equals 4. They're not equal, right? So that's kind of a weird part about fractions. If this is a plus or minus sign in between, you can't cancel individual parts. It has to be all of them. If it's a multiplication sign, for instance, let's say it was 4 times 3 over 4, that equals 12 over 4, which is 3. If I canceled the 4s, I'd get 3 over 1, which is 3. When it's multiplication, you can cancel the individual parts. If it's addition or subtraction, you cannot cancel the individual parts. Okay? And a lot of times when I'm not sure if I can do something, if you're allowed to mathematically do it, I test it with numbers that I know. I try to make up a scenario that's exactly like what's there, but just with numbers to make it a little bit simpler. Okay? So in this case, we can see that we cannot simplify it. The only reason that we're able to do this, what we're technically doing, right? And I don't want to get too complicated because we haven't gotten here yet in the course, right? What we're technically doing is factoring a 4 out of the top. And that gives me -1 plus the square root of 3 over 4 times the square root of 9. Okay. Because I took a 4 out of -4.
But you can't take that 4 out.
Okay, so which 4? You talking about this one on the bottom? Yeah, I took a 4 out. So if I were to distribute this, that'd give me -4 plus 4 root 3. So I factored the 4 out. Okay, the reason we're able to reduce the way we did is because now this is multiplication. 4 times that, 4 times that. Now those 4s can cancel. When it's multiplication, you can cancel the numbers. Okay? We can go further with this now. What's the square root of 9? 3. Now we're finished. Okay? So that one didn't look hard, but it actually was. Okay? Okay, we're going to do another one. Hopefully it'll help you.
So the answer is -1 plus.
-1 plus the square root of 3 over 3.
But then you can cancel. Can't cancel.
No, because one's inside and one's outside. Okay. Okay. All right, let's look at number 5 together. We've got 2 plus the square root of 5 over 3 times the square root of 16. Okay. All right, put your brain in gear. What can we do? Anything?
You can
Make the
simplify
16 plus 4.
Yeah. And so what do we end up with on the bottom? Okay. Can I reduce the 2 and the 12? No.
Why?
Remember what we said up here? It's got to be all of them. Everything. Where was that now? We did it somewhere.
I thought that was just for whatever.
I don't know where we did it. Oh, it was this one. Yeah, okay. Right? It's got to be everything. So, because I can't factor a 2 out there, so it had everything. If there was a 2 in front of this, then I could cancel it. I could reduce. But since there's no 2 in front of that radical, I cannot reduce it. Okay? And the reason goes back to here. The reason I was able to reduce is because I actually factored out a 4, turning it into multiplication. And then the 4 is canceled.
So like for number 3, where it's the 12, the radical 12.
Attention teachers and students, at this time, can we please invite the students that will be meeting their grandparents at Mass over to the church at this time? Thank you.
Where it's the radical 12 over 5, radical 16.
Mm-hmm.
You know how we simplified the 2 and 20?
Where is that? Did I erase it? Oh, here it is. Yes, we can do that because there was only that one term up there.
But so you can't do it if you're like adding.
Right. Okay. Okay, we'll stop there. Yep. Yes. Yes. Yes.
Are we turning these in?
No.
Do I have to wait for,
Have to wait for what?